Hi, this is Mr. Hall. Today I'm going to talk about equivalent fractions. Now, when we talk about equivalent fractions, it's good to know that that just means equal fractions. Two fractions that are equal. First of all, sometimes we run into fractions like 1/4, and then we see another fraction like 2/8. And it says that they're equal to each other. Now that can be confusing because obviously they look quite different. So we're going to talk about how that works. The first thing that I would like to use to show how an equivalent fraction works is my trusty, dusty pizza. All right, so if we were to take this pizza, we're going to cut it into 4 equal slices like that. We could write that we have 4 out of 4 slices of pizza. Now, one thing we need to know with equivalent fractions, if they're equal, we're not going to get rid of anything. We're actually going to keep everything the same. So technically, we still have the same amount of pizza. But if we were to draw more lines, say we were having a party, and first we thought 4 people were going to come, so all we needed was 4 slices of pizza. Then we found out 4 more people were going to come. So quickly, we draw another line through it. We didn't get rid of any pizza. We didn't call and order more pizza. We just separated it a little differently. So now instead of having 4, we have 8 slices of pizza. And 8 of them are there. So hopefully that makes sense as far as equivalent. Okay, we could keep doing this on and on. So say 8 people were coming, and all of a sudden we decided, hey, if those people are coming, we'll just invite more people. So we cut it one more time. We separate each piece. All of a sudden, instead of 8, now we have 16 out of 16, which is still equal to 8/8 or 4/4 because we really didn't get rid of any pizza. We just separated it a little differently. So that's all equivalent fractions really are ways to separate things a little differently. Okay, here's another example for equivalent fractions. Say, for example, I have this box right here. One section of that's filled in. To write that as a fraction would be, let me write that down, 1/3. Now, to find an equivalent fraction for that, or a fraction that's equal, sometimes it's as easy as taking that box and just putting another line through it. Okay? We don't have any more. We didn't add anything. We didn't take away anything. We just separated it a little different. Okay, so where we went from 1/3, now we have 2 out of 6. So if we write that down, 2/6 is equal to 1/3. Okay, we could actually keep doing that more and more. But if what we looked at right now was to say 1 and 2, what times 1 equals 2? Well, 1 times 2 equals 2. Now in fractions, what we do to the top, we do to the bottom. 3 times 2 equals 6. Then we notice kind of a pattern here. Okay, so we could actually do this again. We could go 2 times 2, make sure what we do to the top we do to the bottom, and we could get another equivalent fraction, 4/12. Okay, now to check and make sure that's right, we're going to take our line, draw a line through there. Notice we didn't take away anything, but now we have 4, 8, 12. 1, 2, 3, 4 are shaded in. So we have 4 shaded in out of 12. It's another equivalent fraction. Technically, we could do this forever and ever and keep splitting these up. But it's good to notice that you can actually do it without even drawing the diagram, just by noticing the pattern. 1 times 2 is 2. 3 times 2 is 6. 6 times 2 is 12. 2 times 2 is 4. And we could do it again, and it would become 8/24, and so on.